All right, so I don't remember if we finished this or not, but we're gonna start right here. An angle bisector. So an angle bisector is a ray. It doesn't have to be a ray. It could also just be a line or a segment, but in this case, we're gonna talk about rays that divides an angle into two congruent angles. Really important there. When we're bisecting anything, an angle or a segment, we always have to cut it into equal parts. There's a lot of times people will get confused and they'll think just because a line or a ray is drawn to dividing the angle into two parts, whether they're equal or not, they would call this a bisector. That's not true. A bisector has to go exactly through the middle there and divide it into two equal parts. So in this case, this line, this ray, is a bisector. And you can tell they have some markings here. They have some arcs in there to indicate that these angles that are created are congruent to one another. They're equal angles. Okay. Remember, bisector always splits things into two congruent parts. So that's going to be an important thing. We can use that to help us maybe set up some equations or to figure out different pieces of the angle or the whole angle, depending on what we kind of start with. So that does set up a relationship for us, right? The whole angle, then each of these would be half of the whole angle. Or if I double one of the halves, that would make the whole angle. I can do a lot of different things with that. All right, so we're going to go ahead and go through two example problems. Maybe. Oh, I forgot about that one. Okay, so here we go. We have an example problem. With some of these problems, we're not going to have a picture. So it's important for us to be able to take the given information that we start with and to create a picture. We don't really care that it's exactly accurate to like measurements and stuff. So I don't know how big these angles are going to be. So I don't care if you know, it's supposed to be a 60-degree angle and I draw it like a 30-degree angle. It doesn't really matter. I just want to draw something that kind of matches the description a little bit. So I'm going to be trying to draw QS that bisects angle PQR. I'm going to start with angle PQR. So I'm just going to draw some kind of an angle here. So I've got an angle. And I'm supposed to have a bisector as well. So a bisector. Want it to be in the middle. That looks good enough. All right, so my initial angle is supposed to be called PQR. I know that means that Q is the vertex. And P is on one side of my angle, and R is on the other one. And this bisector, the thing that's cutting it into two equal parts, is supposed to be called QS. So I have a point Q already. So I'll make a point S out here. So now I have a picture that I can start labeling to kind of get an idea of what's going on here. The only thing I'm missing is, since this is a bisector, I know that these two parts are equal to each other. So I can use those arc marks to remind myself that I have some equal angles here. All right, now the measurement of angle PQS is equal to 5y minus 1. Okay, so PQS, that's this angle right here. So one of the halves is 5y minus 1. And the measurement of PQR, so that's the whole big angle, the red lines that I have there. That's 8y plus 12. So for me, just so that I remember that I know the whole angle, I actually just write it near the vertex of the whole angle, just so that I remember this is actually the whole thing. Because it's hard for me to label the whole thing clearly when I have these two parts that are kind of cut up. All right, so our goal is to find the measurement of angle PQS. So when we're asked to find the measurement of a particular angle and we're given these algebraic expressions, we have to actually do two things. We need to be able to set up an equation that lets us solve for our variable. And then we'll need to plug in the solution for our variable in to figure out a particular degree measurement for this angle. All right, so thinking about it, I know one of the parts and I know the whole thing. I could do this a couple different ways. The way I'm going to do it is I'm going to use the angle addition postulate, but there are a couple ways that I could go about doing this. But I'm going to use the angle addition postulate for this one. So the angle addition postulate says that these two angles, we'll call them 1 and 2 for easy communication, says basically that angle 1 plus angle 2 is going to equal angle PQR, the whole thing. Now really I should have the measurements of those angles. So I'll write measurement of those angles. So this angle plus this angle equals the whole thing. That's really all the angle addition postulate tells us about this problem. I know most of the things, I know something for almost all these things. I have a measurement that I can use for angle 1, and I have a measurement that I can use for PQR. Do I know anything that I can use for the measurement of angle 2? Is there anything that's already here that I could also use for the measurement of angle 2? Yeah, go ahead.
8y plus 12.
8y plus 12 is going to be this one. It's going to be the whole big thing.
Oh.
So it's bigger than 2. So here it is. One of these two things can be used though, right? Because since this is a bisector, I can use this to represent the other side because they're supposed to be equal to each other. So I can call this one 5y minus 1 also. Probably have somebody say in the chat. Okay, yeah, that is true, but that wouldn't necessarily give me kind of what I want. That is true, Alyssa. So that was just to me, but there was another thing that was in there. All right, so I'm going to go ahead and set up the equation I have here. So the measurement of angle 1 was 5y minus 1 plus the measurement of angle 2, which is also 5y minus 1, because remember, bisect is cutting into equal parts, so those two parts are equal. And those are going to equal the whole thing, which was 8y plus 12. So now if I solve this, I'll figure out the value of y that works in this problem. I'll combine like terms. And then I need to start solving, so I need to get my variables on one side. I'm going to go ahead and subtract 8y to get rid of it here. And then I need to get all my numbers on the other side, so I'll have to get rid of this minus 2. You could do this in a different order, different steps, as long as you're solving this correctly. And then I just need to divide by 2. And there's a lot of temptation right here to go ahead and stop, to say, okay, I figured out y is 7, that's my solution. I'm most of the way there. I've done kind of most of the difficult work. Now I need to make sure that I'm answering the final question here. What is the measurement of angle PQS? Well, PQS is this part right here. And that's being represented by 5y minus 1. So I'm going to take the value of y and substitute it into there. So the measurement of angle PQS is going to equal 5 times y, which was 7, minus 1. Doing those calculations, I figure out that's 34 degrees. And so this would be our overall answer for the measurement of angle PQS. And I could go ahead and take that value of y and figure out any of the angles that I wanted to in here, including the whole thing. But the only one we were asked for was this one, right? Is this okay? So this is one way that we can solve these sort of angle problems. We can use the angle addition postulate. And I also made use of the bisector relationship. Since this angle was bisected, the two parts were equal. We're going to do another example that will be slightly different than this, another way that we can solve some angle problems, depending on what information we're given and what we're trying to figure out. So I'm going to go ahead and clear this off and bring up the next one. Okay, so now we have JK bisects angle LJM. I'm going to go ahead and draw an angle. Oops, keep doing that. So LJM, let's just, this will be my angle LJM. So we'll put an L, and then a J, and then an M. Again, I don't know how big to make this angle. I drew an obtuse angle this time. It doesn't really matter what it looks like as long as it kind of fits the description. I have an angle, and then I'm going to draw a bisector as well. So I'm going to bisect it with JK. So starting at J, and I'll have another point on here named K. So this point would be K. And it says that it's a bisector, so I want to make sure to remember to mark that. So this angle and this angle are equal to each other because it is a bisector. All right, now that I have a picture, I can kind of see visually what's going on. I can start labeling the different things. So I want to take my information here. It says that the measurement of angle LJK is negative 10x plus 3. So LJK. So that's this angle here when I trace those letters. So this one is negative 10x plus 3 degrees. So that's this side right here. We could also call it angle 1 and 2 if we want, just for simplicity, but LJK. And KJM, so KJM. So that's the other side. That's this one right here, negative x plus 21. That one is angle 2, KJM. All right. So this one is different from the last one because I don't have anything for the whole angle. I don't know, I'm not given an expression for the whole angle. But, so that means I'm not going to be using the segment addition postulate. I'm not going to say the two pieces add together to equal the whole. What I am going to do instead is make use of this right here, the idea of it bisecting the angle. Since this ray cuts the big angle in half, I know that these two halves have to be equal to each other. So I know that negative 10x plus 3 must be equal to the other part, negative x plus 21. And by solving this equation, I should be able to figure out what I need to do. In the end, keep in mind what our goal is, LJ. I do want to figure out what the whole angle equals, so I'll have to do something with x once I solve it. So I'll go ahead and quickly solve this. Again, a lot of ways we could solve an equation like this. This is just one way. So I got negative 2 for x. I did it pretty quickly, but I just want to save the time there. So negative 2 is the value of x. Now I want to figure out LJM. So I actually need to figure out the whole angle. There's a few ways we could do this. I could figure out both of these and then just add them together. I could figure out one of them and just double it. That's probably the fastest way if I just figure out one and then double it. It's 21. The whole thing's probably not 21, right? All right, so I'm just gonna go ahead and figure out one of the angles and double it. So this one would be, oh, the time. Yeah, we got 1 minute left. This is the last thing we're doing, so negative x, so negative negative 2 plus 21. That becomes 2 plus 21. So this angle is 23 degrees, which means this angle is also 23 degrees. So the whole angle, measurement of angle LJM, is going to be 23 plus 23, 46 degrees. All right, so we're going to go ahead and stop there. The homework problems are posted on Google Classroom for 1.3. The only other thing I want you to do is to do the quiz and preview section 1.4 with that video. Preview that just before Monday. You don't have to do any problems or anything with that. Just watch the video. Remember to come to my office hours today if you have any questions at 1:30.